Good afternoon, my name is Katie Skillington.
And I'm Jim Stewart.
And together we're pleased to share with you our presentation, Passive Aggressive, Instilling Technical Aptitude in Architectural Students via a Passive House Focused Design Studio. The Passive Aggressive Studio is something that we've been co-teaching at the University of Melbourne now for 2 semesters. So we know in the program for this conference, this presentation is a little bit different to many. We're not presenting a built project and it's not any kind of new innovation. Instead, we're talking about how Passive House could be implemented in the architectural program of an architecture student.
The Passive Aggressive Design Studio ran in Semester 2 2019 and Semester 1 2020 in the Melbourne School of Design at the University of Melbourne, with support provided by Fender Katzleaders. Passive Aggressive is what we call a design studio with a technical component, because it requires students to implement Passive House principles in their design work. Our motivation for running the studio was our personal experience of seeing graduates enter the workforce with a notable gap in their education.
In 2006, the late Edward Allen, an architect, educator at MIT, and recipient of the Topaz Medallion for Excellence in Architectural Education, pretty clearly and succinctly framed this gap in his keynote address to the Building Technology Educators Symposium. We graduate generation after generation of students who are not broadly competent and whose design work suffers from a lack of understanding of the technical means by which we build. Why does this happen? The simple answer is because of the gap, that huge bottomless gulf that separates the design studios from the technical courses in most schools of architecture. So this statement resonated with us both, as we felt that students were mostly, though not exclusively, receiving ESD-related content in architectural education in subjects that were largely separate from the design studio environment. This had been our experience when we studied architecture at the same school between 2006 and 2012, and it's also what we learnt when we looked at past years of studios having been offered at various Melbourne institutions. While subjects that teach ESD outside the design studio environment provide students with basic theory, and in some cases practical skills that may be built upon, integrating technical aptitude into the design studio experience opens students up to a possibility of implementing this knowledge within the context of their own designs and as part of their design process. Importantly, by integrating the Passive House principles into a design studio environment, we can effectively get students thinking beyond slap-on additive active technologies and get them back to basics and designing with passive design principles at the forefront of their mind.
So today we're going to show you what the Passive Aggressive Studio is in the context of the educational system that it's delivered in, delve into how we teach Passive House to students who have little experience with the practical use of ESD, the challenges and opportunities we've encountered along the way, and share some of the students' experiences from the studio. We'll also talk about how we as an industry and collection of professionals can better support Passive House being introduced into universities' environments.
So Passive Aggressive was an idea that we came up with when we were both living in Japan. Jim had just been to the second Passive House Asia conference in Tokyo, which was ironically being held at the university I was studying at the time. I was doing a second master's over there. And so the confluence of the conference and its location being like a few buildings away from my faculty got us talking about how Passive House could be introduced to students earlier. We're both architects, we're both former board members of AFA from really, really early on. Jim consults on Passive House projects and I'm targeting a career in academia somewhere in the very distant future. So we thought that we were both pretty well placed to at least have a go at getting a design studio off the ground when we returned to Australia. So after a bit of umming and ahhing for a few years, Passive Aggressive was eventually established in Semester 2 at the University of Melbourne, and we expressly aimed to address the gap between design and technical education in any kind of small way we could. The studio, what it does is it challenges traditional ideas around how we design, construct, and occupy the spaces that house our daily activities. We intentionally focus on residential environments and we get students to develop responses on a micro and macro scale.
So in this studio, students are tasked with designing for current and changing climatic conditions, so that's the passive component, whilst exploring a passionate, well-articulated and individual expression of what it means to dwell in a place. That's the aggressive component. So in the studio, the Passive House standard is introduced to help understand and quantify the implications of students' design decisions around form, orientation, glazing, and envelope design. We don't apply it in a strict sense, and we don't go into the level of detail that you would expect from a consultant, of course, but instead we focus on delivering a sound understanding of the principles of the standard and how they may be applied to affect the environmental performance of students' creations. In both semesters, students were tasked with applying the standard to 2 design tasks: a small footprint building as a warm-up exercise and a larger urban project as their major design task.
So for some context, the studio is delivered in the Master of Architecture program at the University of Melbourne, and each semester there are about 30 to 40 different studios that are run by professionals and academics. All the studios are vertically integrated, which means we receive students who may be in their first, second or third semester of their masters. Students may be from overseas, or they may be local domestic students. They may have completed their undergraduate architecture education at UniMelb, or they may have come from a completely different institution, either in Australia or abroad. As co-studio leaders, we design the studio around a framework of competencies that need to be covered, which is in turn approved by the faculty. And then we pitch the studio to the cohort, who then submit their preferences regarding what studio they want to do. Now, historically, the studio has surprisingly been quite popular. In our first semester, we were quite nervous that anyone would actually want to do it. But it ended up being the 6th most popular out of approximately 35 studios that were on offer. And then in our second iteration, while we don't have the stats regarding the preferences, we did see a lot of referral students. So those are students who had friends that did the first studio and then recommended it to them. When it comes to delivering content, it's important to know that we are very much delivering a Passive House light experience, because it's really important to understand that this is done in an educational environment where the design is paramount. So now we're going to dive into some of the detail as to how we incorporate Passive House into design studio teaching. And there are basically 3 parts to what we try and do. The first is we try to teach the technical content, so the ins and the outs and the technical knowledge that support the Passive House principles. We also try to explore the experience of space and design. And lastly, we apply the principles in a hands-on way to students, on their own actual design work. When it comes to teaching technical content, we really have to start at the beginning. Even though this is a master's level studio, we can get students from all different backgrounds, different education histories, and some of them with different levels of work experience. Because of this, we can't assume that students have a particular understanding of how heat flows in and out of buildings, or how insulation works, or even how shading keeps sun off windows.
And so the first few weeks is a bit of a crash course on some super basic thermal physics, radiant, conductive and convective heat flows, and what it means to control these through building design and fabric. This is a challenge, of course, because we don't want to lose the interest of those who do understand these things, but at the same time we don't want to leave anyone behind. So it's a bit of a delicate balancing act. As we cover each of the basics, insulation, glazing, shading, airtightness, we also explain how they're measured, how they're detailed, and how they're quantified in PHPP. We're fortunate to be able to share with them some construction drawings of some interesting and challenging projects, so they can learn, for example, what it means when your structure is a cantilevered steel frame, or you want a beautiful edge-to-edge corner between glass and weatherboard cladding.
The second part is around experiencing space and design, and this is where we're really heavily reliant on the wonderful help from our friends and colleagues in the Passive House community. Of course, we start by showing students some great examples of Passive House designs from all over the world, different shapes, different sizes, different building typologies, different styles, different materialities. It's really important, in a design studio particularly, for them to understand that Passive House, or any sustainable design approach for that matter, is not a style of its own, and it's not there to limit their creative freedom. But infinitely more valuable than a slideshow in a classroom is real-world touch and feel. In semester 2 last year, we were fortunate to visit Claire Parry's home renovation in Melbourne in the later stages of construction, and we got a surprise visit from the architect, Michael Markham, and some great stories were shared amongst the group. We also managed to arrange an extensive tour of Gillies Hall at Monash University. The students genuinely came away amazed at the feeling of that building. So the sense of quiet, the fresh air, especially in a student accommodation project, I think a lot of them went into it expecting it to be a bit stinky. The way that the windows worked, a lot of them were just fascinated by tilt-turn windows. And so as a result, it was really eye-opening for them, especially so in a building typology that so many of them were familiar with and actually living in at the time. And then 2020 threw us a curveball, and we weren't able to replicate the same physical experience. We started teaching face-to-face, but like the rest of the world, we ended up going online in week 3, which was an insane challenge. But we still made the most of every opportunity that we could for guest interaction. And we're really thankful to Johanna Trickett, Walter Vanderlind and Kate Nason for sharing their project experiences with our studio online, and then talking also to students one-on-one about their designs. But of course, we really do hope that the next iteration of Passive Aggressive will see us back out there in the real world and getting our students able to touch and smell and listen to Passive House spaces. And for this reason, we're currently not teaching the studio this semester because it's still online teaching, and we probably won't return until we can go back to full-time face-to-face.
So lastly and most importantly is how we get students to apply the principles hands-on. To do this, we've developed a heavily simplified single worksheet interface to sit over PHPP, with the express aim of being a teaching and learning tool that provides instantaneous feedback as students try different things with their design. So in a 12-week studio with a design focus, it's simply impossible and impractical to get students using PHPP in full. So on the left-hand side, we have an energy summary which shows the all-important annual heating and cooling demands, as well as basics like treated floor area, external envelope area and resulting form factor, and glazing orientations. This provides live feedback as students complete the rest of the sheet, and it exports as a stamp for them to place on their final panels. Moving to the right, the first step is for students to enter the basic geometry of their design. So treated floor area, floor envelope area, wall envelope area, and roof envelope area. Effectively, this is an opportunity to learn about that most fundamental of passive design considerations, form factor. We stress in the studio that we don't want everyone to design cubes or spheres, but that we do want them to understand the implications of more complex shapes. We want them to understand that more surface area means both more cost and either thicker insulation or worse performance. The second step is to play with some of the key values that determine building performance. So we ask them to rate how lightweight or massive their building is, depending on what materiality that they're intending to use, and see how this affects performance, so trying different values. We say that they can assume 0.6 air changes per hour for their final design, but we also ask them to play with this value and see what happens if it's 5 or if it's 15 instead. It's a residential studio, their projects are residential, so they key in how many dwellings are in the building for the sake of internal heat gains. And then the first time we ran this studio, we asked them to enter all the details of the wall, floor and roof build-ups. So basically completing a stripped down version of the U-values sheet. But we found inevitably this led to a deal of confusion and time lost that we felt could have been better spent elsewhere. So for the second iteration, as you see here, we simply asked them to enter R values for wall, floor and roof insulation. This gives them, immediate feedback of what thickness to allow for in their details. And then on the back end, we've built in typical assumptions for framing and claddings and the like. Glass is similar. We built in assumptions for frame values and such, but we asked students to play with the G value and the UG value to balance summer and winter performance and see what different values deliver. And lastly, there's a simple checkbox to see what difference can be made simply by opening windows overnight in summer. Then moving across, the third and final part of the spreadsheet is windows and shading. And this will be immediately familiar to anyone who's used PHPP. It's the most detailed and true to life part of what we ask the students to do out of necessity, as I'm sure you can all relate to. There's still an element of simplification in there, but there's enough detail retained for students to grasp the implications of size, orientation and shading characteristics for all the glazed elements in their designs.
Once the students have resolved their designs and fine-tuned performance in the spreadsheet, the last thing we ask them to do is that they prepare a section detail demonstrating how they incorporate the amount of insulation they've specified, how they avoid thermal bridges, how they might treat their window reveals, and so on. This is something that some students have absolutely zero experience in doing at all, or if they do, it's often in the abstract sense of having redrawn someone else's detail in a construction subject. Very few of them have ever considered how construction details can actually inform and reinforce their designs. And some students hate it, of course, like you just have students that just don't like detailing for whatever reason. But a surprising number of them have actually relished this part of the studio and say it opens their eyes to the architectural considerations that they've never previously thought of.
So that basically sums up what we do and how we implement Passive House within a design studio. Teaching technical content, experiencing space and design, and applying the principles hands-on.
So over the 2 semesters that we've taught, we've had students present some really great work. The first semester saw students design a small house, which had a size limit of 60 square metres, and it was located on a rural site, so it was like a baptism of fire when it came to Passive House. And then for their major project, they did an urban infill accommodation design. And then in the second iteration, which we aptly called Passive Aggressive Reheated, students had an experiential space that they had to focus on for their first design exercise, and that had to express a core experience of dwelling. So they had to create a building for eating, or a building for resting, or a building for bathing. And then for their final major project, just like the first semester, they had an urban infill accommodation building. For all the projects, except for the experiential space in the second semester we taught, the spreadsheet and the detail were required.
Images of student work are nice artifacts of the studio experience. However, images alone don't really tell us what a student's experience of being exposed to Passive House was. So to understand the impact of the studio on the learning experience, we had our students also complete a written reflection at the end of the semester on 2 things: what they thought of the standard and what they thought of the studio itself.
So when it came to reflections on the Passive House standard, we had some really interesting opinions that we thought might be interesting to share. So in our first semester, our top student, Stella, noted that she saw the Passive House standard as being part of the puzzle. So she noted that the standard alone is an incomplete view of sustainability, but definitely a critical step in the process. Others found that historically the standard was quite limiting when it came to architectural expression, and some other students took a more critical stance to Australia's participation in the global Passive House landscape, noting that they found it disappointing that Passive House was still very much a niche in Australia. One of our more insightful, mature age students from the past semester noted that from the outside, Passive House can come across as elite and unattainable for most. And in Australia, for the most part, this may be the case for the moment. However, after my introduction to Passive House throughout the semester, I have seen it is much simpler than I had first imagined. When it came to the actual studio experience, we were happy to see that our motivations for running the studio to bridge that gap between design studio and technical education were not unfounded. Students noted that until this studio, most ESD related content had been taught with little understanding regarding its application in design, and through the studio experience, students had begun to understand the benefit to learning about ESD from the perspective of application.
In our experience, there have been some challenges to teaching a Passive House focused design studio, namely fitting in with the institution and also the students' interpretations of the standard. Firstly, fitting in. The design studio program at MSD and many other architecture schools is great in the sense that as co-studio leaders, we're afforded a great deal of autonomy in how we operate. However, when it comes to assessment, you are moderated against other studios in the program, the majority of which don't introduce the same level of technical requirements that we placed on our students. This really limits how far we can take Passive House, or how far we can take any technical side of the studio, because we are forever conscious of how our students' work will stack up against the outcomes of more standard or traditional studios that were solely focused on design, some being quite speculative and others barely generating a recognisable building per se. Although we are keen for our studios to have a slightly more vocational flavour and prepare more work-ready graduates, which would satisfy the desire from industry to have more work-ready graduates according to a recent report, we do walk a fine line to achieve a balance between the speculative and the feasible. And as a result, we end up preferring to teach and demonstrate the Passive House principles in our studio rather than an extensive exploration of the standard and its more technical nuances.
So another challenge we found was how students interpret the standard, which we didn't actually foresee when we were planning our first studio. We found that there was definitely a spectrum of responses to the technical requirements that we placed on students. So we had some students who used the technical requirements and the Passive House principles as an excuse to limit creative expression. So they'd lean on the efficiency and comfort argument for what was, to be honest, inherently an uninspired and underdeveloped creative proposition. But then at the other end of the spectrum, we had some students choose to design first and then try to retroactively apply the standard, and then getting over the line with respect to the annual heating and cooling load requirements that we'd set by specifying simply unfeasible glazing and insulation combinations. So we suspect that this retroactive application is due to students having pretty limited experience using basic passive solar design principles in their work as the norm, and understanding the real-world implications of material choices. Most students anecdotally told us that to date, their experience with ESD in the educational setting was more focused on specifying and sizing active systems rather than fundamentally understanding the implications of basic design decisions such as glazing, fabric and orientation. Now, as much as there are challenges, there are also a lot of opportunities to teaching Passive House via Design Studio, but also just bringing it into the university environment. So firstly, Passive House Design Studios are a great vehicle for promoting Passive House.
Secondly, we think Passive House as a framework is a great mechanism for delivering a practical understanding of general passive design strategies. So going beyond theoretical understanding and getting students to exercise that strategy in their work. Although for older generation architects and those of us with an active understanding of these principles, this may seem like very low-hanging fruit, you'd be surprised just how little experience students have in actually using these principles in their own work. Another reason we think Passive House is great for reinforcing these basic principles is PHPP itself. The fact that it uses a spreadsheet base means that it's easy for us to adapt the interface into a simple and valuable learning tool, as we've shown, regardless of what drafting program or modelling program students might be familiar with. And By virtue of its monthly calculations, it can provide that instantaneous feedback to trial and error inputs in a way that most energy modelling tools can't.
So currently, we're not aware of any other architecture design studios that are implementing Passive House as a core part of their curriculum in the South Pacific region. But if you are, let's have a chat. We'd really be interested to hear. But if you think about it, with universities, just, if you think about it alone, in the Melbourne and Geelong corridor, they are graduating over 1,000 Master of Architecture graduates each year. And some universities, like Monash University, are really heavily pursuing the Passive House standard in upgrading and developing their building stock. So we think that there is definitely scope for better support for Passive House education in the university environment. So the big question is, how can Passive House and how can the Passive House community better support getting the standard onto university radars? So one of the more accessible ways for practitioners to get into universities is via casual teaching. Any kind of guest opportunity that you're offered at a university, like a guest lecture or being a design crit, or if you're asked to do a technical tutorial about a certain aspect of Passive House, then we seriously consider that you should be encouraged to do it as much as you can. Every architecture school will have sessional or casual teaching positions open most semesters, and some will have design studios also open to application. And it'd be great to see studios similar to Passive Aggressive in other places, or if they're already happening, we'd also be really keen to hear about them. We're also open to talking to people who are thinking about running a Passive House focused design studio in other cities, but they might be unsure about where to start. Another way to get Passive House into universities and on the radar of students is via improved access to Passive House training. So we found at the end of our semester, when we were talking to our graduates from the Passive Aggressive studio, we found that there was definitely an appetite for students to go the next step and do the designer's course. But for many of them, the current course offerings are just too cost prohibitive. So if you think about it, students are already incurring, quite significant HECS debts to study architecture, or you've got international students who are paying upfront fees of some $30,000 a year. So an additional $3,500 in fees to do the Certified Passive House Designer course is well beyond most of their means. However, we can see such a course that was obviously bolstered by some design exercises and outcomes that would be perhaps more palatable to a design school, being potentially deliverable across a typical university semester or semesters as an elective subject, and the exam being perhaps offered as an add-on option at an additional cost. And we'd be really interested to chat with anyone who is doing something similar or knows of something similar being implemented.
Ultimately, we believe that integrating ESD education within the design studio environment is critically important to developing ESD literacy in the next generation of built environment professionals. Passive House, we think, is the perfect vehicle for this aim due to its physics first, fabric first approach and its proven performance.
We're not motivated to continue on this path because we want to flood the market full of certified designers or consultants. That's definitely not in our intentions at all. But we are really passionate about pursuing this direction because we know that with better knowledge, better technical aptitude, and quasi-practical experience, these future employees will be much better equipped to have discussions with consultants about the fundamentals of ESD in the projects that they're delivering. In fewer circumstances, it may lead to some architectural graduates pursuing a new career path in ESD consulting. However, regardless, it'll hopefully bring Passive House to a newer era of architectural projects at a time when, and in a region where, thermal comfort and energy efficiency could not be more important. Thanks very much.
Thank you.